Good afternoon, everyone, and maybe good morning, depending on where you are. Welcome to this SFU Data Science Research Group seminar series on trustworthy data science and AI. Today, we are extremely excited to welcome Dr. Luna Dong to present a talk on next generation intelligent assistants for AR and VR devices. Luna is well known in the whole area of data management, and she is the head scientist at Facebook AR/VR Assistant. Prior to joining Facebook, she indeed works in almost major internet companies in Silicon Valley, including Amazon, leading the efforts of Amazon product knowledge graph, and the Google knowledge value vault project, and also did this Google Choose Machine project, and highlighted by Washington Post. She has co-authored well-known books like the Machine Knowledge, Creation and Curation of Comprehensive Knowledge Bases, and Big Data Integration. And she is an ACM Distinguished Member and also the VLDB Early Career Research Contribution Award for advancing the state of the art of knowledge fusion. And she is serving in the VLDB Endowment and the PVLDB Advisory Committee. And she's a PC co-chair for KDD 2022 ADS track this year. We are waiting for her decision on our submissions in just a few days. Yes, so, and she also was a PC co-chair of VLDB 2021 and a Sycamore 2018. Without further ado, let's welcome Luna to address us. Thank you, Luna. The stage is yours.
Thanks a lot for the introduction. Hi, everyone. I'm Luna from Meta. And as you possibly know, the company was named Facebook before. And today it is my great honor and pleasure to present my current work at Meta regarding building intelligent assistants for AR, VR devices. Okay, so when we talk about assistant, intelligent assistant, I'm wondering what will come to your mind. So maybe you are thinking, yeah, the intelligent assistant could respond to commands. You can say, hey, Siri, set a timer to 7 p.m. and it will do it for you. It could control some of the devices for you. For example, you could say, hey, Alexa, turn off bedroom lights. And then your lights is down. And this is actually my top one use case from Alexa. And the top two is listening to music. And you can also get some information from the assistant. And you can ask, hey, Google, when is Easter? And it will tell you, hey, this will be Sunday, April 17th. And certainly you can get other information, the simple thing, including like the weather, the time, and there are way more information you can get from the assistants. And at Meta, we also develop assistants. And our goal is to empower the connection to people and the experiences in the user's life. And the assistant helps Facebook portal. And you can just say, hey, portal, call someone, and you can do some hands-free call. You can also get help regarding music, timer, alarm, weather. You can see the photos from your Facebook profile, and there are many, many more functions you can get. The assistant also helps the VR glasses. And I don't know if you have tried Quest or Oculus, and you can say, hey, Facebook, who is online, and you can start it hangout with your virtual friends, and you can open a particular game and start straight with that game, and so on. And the last year, I think it is roughly like September time, Facebook launched the Ray-Ban stories, the smart glasses. I actually planned to bring it here, but forgot. And when you wear the glasses, you could say, hey, Facebook, take a picture. And then even if you are biking, you are skiing, you can take a picture hands-free. You can also take a short video, and you can just talk to your glasses to call your friends on Facebook Messenger. You can manage the device, and there will be new features coming up as well. Okay, so what is an ideal assistant? Everyone deserves an assistant, and if you have an assistant, what would you want her to do for you? And the assistant should follow your instructions. And when you ask him or her to do something, hopefully it will do it for you. And the assistant should know you well and would know what you need. And possibly, even without you asking, it already know what you want. The assistant should be capable, and it could do those things that you want it to do. And finally, last but not least, the assistant should be knowledgeable, because only if it is knowledgeable, it can be capable, and it can sort of better serve you. And similarly, for a virtual intelligent assistant, ideally, it should know you and the world well. In other words, it has public knowledge, it has personal knowledge about the user. It can receive your requests or predict your needs. And when it receives your requests, it serves you in a reactive way. And when it predicts your needs, it serves you in a proactive way. And it should provide you the right services at the right time. And certainly all of this is with your permission, and you are still the master. So there have been 3 generations of intelligent assistant. And actually here, the first and the second generation are very close and possibly are even considered as the same generation for many different people. So instead of using V1, V2, I used the V0.1 and V1. The V0.1 virtual assistant is a chatbot. So you input the text and it will return answers. And the next real assistant that we are normally sort of interacting with is voice assistant. And this is like, as I have shown, Alexa, Amazon Alexa, Google Home, Apple Siri, Microsoft Cortana. And the next generation, V2, is kind of the AR, VR assistant. In addition to the voice input, not only you can talk to it, but also it gets visual input and it knows the context. And I will tell you more about what is context. So in this talk, we have just talked about what is an intelligent assistant. And next, I will briefly cover what are the techniques to support current intelligent assistant, and then what are the challenges to build the next generation of AR, VR assistants, and what are our initial solutions. My goal of this talk is not to tell you how to build the next generation assistants, because I don't know. And my goal is to impress you with the many machine learning fields that are touched by building an intelligent assistant, to introduce you the many interesting research problems we need to solve. And hopefully together we can we can open the new doors to build those assistants and to make our lives much better. So with this, up to now, any question, please feel free to ask questions even during the talk. Okay, if no question for now, let's move on. Let's first see what are the techniques that enable the current intelligent assistants. So recall our 3 examples. Set a timer, and that's where we might invoke an app. Turn on the lights, that's where we control the device. And asking a question, and that is where we get the information from external data sources such as the web or some knowledge graphs. And we can actually categorize all of the demands or commands to the intelligent assistants into 2 categories. Either it is task-driven, it does something for you, or it is information-driven, it provides you the information. And an intelligent assistant is essentially a conversation system. And here I'm showing an example architecture of an intelligent assistant. And let me use a task-driven command as an example to illustrate this. So you say something to the assistant, turn on the lights. And the first component is ASR, Automatic Speech Recognizer, which turns it into text. And then now you have the text to turn on lights. That's what you are saying. The next component is natural language understanding. And what it does is to turn this unstructured text into some structured form to tell you what is the intent. The intent is to turn on device. And what is the particular slot. And here the slot for device turn on is, we need to know the device. And here, let's assume you have only 1 light, and then it will say, okay, lights number 1. So after that, the dialogue state tracker taking the intent and it would say, okay, the action type is turn on and the device is lights number 1. The current status for the lights is, it is off. And then dialogue policy component will take this status and send some demand for the device. And here the agent is smart light. It will say, okay, turn on this particular lights. And then meanwhile, as you can see, it switch the status from off to on and send back some status. Oh, it succeeds. So next, the natural language generator component, this is the NLG component. It will take the status and generate some response to the user. And it might say, hey, lights turned on. This is more of a confirmation. And that text is transferred to speech to voice by the TTS component. And then the user would hear the response from the assistant. So that's the whole process for 1 round conversation. And the response is basically a confirmation. What about 2 rounds? When we come to 2 rounds, oftentimes it is because we need some clarification questions. And let's say you also say turn on lights, but there are 5 different lights registered with the device, with the assistant. And the assistant can understand your intent, but it does not fully understand which particular device you are talking about. And then it will update the state saying, okay, the device is missing, and then generate some clarification questions like which lights to turn on. So for the next round, the user would say, oh, bedroom lights. And now the NLU will be able to link bedroom lights to the registered lights number 2. And then it updates the dialog, send the command to the devices saying turn on lights number 2. And if it succeeds, it will say bedroom lights are turned on as a confirmation. So this is a typical 2-round conversation dialogue. Certainly, sometimes there might be multiple rounds for clarification, But another possibility for multi-round conversation is there could be some follow-up requests. And you turn on the lights, and if it is too bright, and you would say, hey, dim the lights. And this time with co-reference, the NLU component will understand the lights you are talking about is the same lights as last round, and that's light number 2. And then it will dim the light and say the bedroom lights are dimmed to 5. And this can just continue. And you can, in addition to tasks, you can ask for some information. You can say, oh, how many people does it take to change its bulb? And then the assistant will advise you 3, you have 1 hold the bulb and 2 to turn the ladder. And here I'm certainly kidding, but this is more of getting some information from the knowledge graph or from the web. And once it comes to answering questions, providing information, it will be slightly different. And that comes to all of this QA, information retrieval, etc. So as you can see, we have 3 main sort of blocks. One is to understand the user's request. One is to plan what action to take and fulfill that actions. And the third one is to generate the response to the users. Another way to look at it is one part of it is speech. You understand the speech, transfer it to speech from text to speech, or from speech to text, or do it in the opposite way when you generate the response. And another big chunk is dialogue. And this is kind of the conversational AI stuff. And certainly there are different variations for the conversational system. And one obvious variation is you might be hearing a lot about end-to-end NLP systems. And we can have, instead of all of the different components, we might have end-to-end dialogue system. And it gets the text input, and then it just output the text response, commands to the devices, and also like status. Another potential variation is that instead of having control the app's devices directly, we have an army of specialized assistants. We have music assistants and maybe multiple music assistants. We have movie assistants, shopping assistants, and so on. And then the assistant, the meta assistant is playing a role to direct your command to the right specialized assistant. And actually, Alexa is taking this model. There are possibly millions of different like Alexa skills. And when you ask for something, Alexa will decide, okay, which particular skill to invoke. So there are a lot of research areas related to this. Speech recognition to handle the speech. For dialogue, this is conversational AI. And I have been mentioning semantic parsing for NLU, entity linking for NLU, co-referencing, dialogue status, co-referencing also here for NLU. And meanwhile, dialogue status tracking, language, this is for dialogue part, language generation for this component, so on and so forth. If we got information-driven questions, commands, we basically need to figure out how to build a knowledge graph, how to answer the questions using the web information and the knowledge graph, and how to do information retrieval. Okay, so there have been a lot of research on this, and we have seen a lot of quite successful products as personal assistants, intelligent assistants in industry. But is it all done? Not yet. And there are still many things we can improve. How can we increase the accuracy of the results? And how can we improve the recall instead of saying, sorry, I don't understand what you are saying? Can we sort of reduce those sort of percentage of such cases? And another thing is how to allow easy scale up to new tasks, to new domains, to new languages. Scaling up is always important to have some like a comprehensive assistance. And how can we make the assistants more knowledgeable and make it a know-it-all? And as you can see, the second part is more of a capable. First and the second part is capable, and the third part is knowledgeable, as we have just said regarding ideal assistants. And when there are multi-turn conversations, how can we make it smoother? All of this can be improved. So let me pause here. Any questions so far?
Hello, Dr. Dong. I just have a quick question regarding those assistant devices. So does it also cover, like, for example, someone has difficulty to speak, right? Or they have a disability. While those interaction also consider those aspects and make like interaction more user-friendly and for those kind of population, yeah.
Yes, yeah. So that's a great question. And I know there are skills developed for kind of disabled people. And as an example, I definitely heard those things where it could transcribe stuff for you. And let's say when I say something, the assistant could sort of hear what I'm saying and transcribe that, put it into text and show it on the screen. And those could help people who are disabled.
Okay, great. Yeah, thank you for sharing that.
Okay, so if no more question, let's move on to the next generation. We have already went through the first generation. There is one question in the chat room asking how complex is the state section after NLU? I've only ever had shallow state interactions, and by state section after NLU, I guess you are talking more about here for dialogue state tracker, right? Okay, cool. And so this is actually a great question. And in our team, we have proposed, this is the publication a couple of years ago, where we allow tracking dialogue states from like for nested demands. And for example, you could say the direction to the ballet performance. And so the first level of intent is to get the direction. And the second level intent is to get the location for the ballet performance. And there is such proposals regarding how this should look like and how we should represent that, capture that, and how we can understand the text and generate those like nested intent and the slots. Does this answer your question? Okay. Okay, sounds great. Another question from Kanyan Chen.
Hello, Professor Dong. Yeah, I have a question about, I'm a PhD student from Illinois Institute of Technology, and I'm curious, a question about the intelligent intelligent assistant system consists of many components, right? And I'm curious about whether or not the system running on the end devices or server, because I'm curious about can we interact with the system very fast? Yeah, thanks.
That's a great question. So for Alexa, for Google Home, as much as I know, it is running on the cloud side. So it is running on the server side. But I'm going to talk about this in the next section regarding moving to the device side.
Okay, so it is a system consists of the end devices and the central server, right?
Sorry, say it again, please.
Can we consider it as a Federated Learning, maybe Federated Learning system, maybe?
So the learning is definitely at the server side, but where to run the models, and the majority, I mean, I would say first generation devices are mostly running, doing the inference, running the models on the server side. But okay. I will soon tell you for the second generation why it is so critical to do it on the device.
Okay, thank you. Thank you.
Okay, let's move on. And let's first revisit what we are thinking about for ideal assistants. And we have talked about knowing you and the world. That's the knowledge graph part. We have been talking about receive your requests. And we have been talking about find the right services. And that's based on some good understanding of the requests from the users. So far, we haven't talked much about predict your needs at the right time, and soon we will get to it. Okay, what are the challenges when we talk about AR, VR assistants? And let's first consider why those AR, VR assistants should be different from the current voice assistants. So let's say you have an AR glasses or smart glasses, you wear it and you see through it. That is how it is different from this like a speaker you put on the kitchen counter table. And in addition, you wear it everywhere. It is not just staying in your kitchen, it could go with you to different places. And because you wear it, and you might wear it for a long time, and so it knows you better. And finally, because you wear it everywhere for a long time, you may not always have connection. So what does this mean? So first, you see through it, and so now the assistant does not need to be voice only. It gets the voice input, it also gets the multimodal input, vision input, and it could do the multimodal reasoning. Previously, you could ask how tall is Empire State Building, and then now you could look at something and ask, what's the name of this building and how tall is it? Because you wear it everywhere, so it understands your context, where you are, what is the time, so on and so forth, what you are doing. And so the system can go from context agnostic to context aware. And previously you might ask, show my shopping list. And then now as you walk in the street, the assistant might say, remember to buy apples and bananas on your shopping list at the grocery store around the corner. And because you wear your glasses for a long time, it knows you better, and it can predict your needs better. Previously, it is more in the reactive mode. You ask, what's the weather today? And then now it could be more proactively. In the morning when you put on your glasses, it might say, hey, today is sunny, 70 degrees. Would you like to play your favorite morning music as part of your morning routine? And finally, this is related to the question we just heard, because you do not always have connection. And so we cannot always just rely on the server side computations and inference. And so we need to move from server side to on device. And an extra bonus for this, and this is actually at Meta, it is not only the bonus, it is kind of one of the motivations to do this is it helps you protect your user data, protect your privacy. Okay. So with all of this, there are several research directions. And let me start with this one because this is so sort of a fundamental one. And the first direction is on-device machine learning. So it's the same stuff, but instead of running at the server side, we might want to do it on the device. So let me use one of the components. This is NLU, natural language understanding, to illustrate how we could do this on the device. And what is the restriction for the device? It is much smaller memory, and the computation power or computation capacity could be much lower. Okay, so for NLU, we do semantic parsing, and the input could be something like message, I will be there at 6 p.m. And this is pure text. And the output is the intent structured form. For example, the intent is send message, and the slot for content is I will be there at 6 p.m. And how do we transform from the input to the output? Possibly without any surprise to you, we do sequence to sequence. And we encode the input, and then we decode it to the structured form. And this is kind of the traditional autoregressive semantic parsing approach. The pros for this approach is it has high accuracy, but the cons is it's just so expensive when you do it sort of in a sequence. And this basically means we need to do it at the server side mostly. And if you do not have good internet connectivity, it is flaky user experiences. And because data needs to transfer between server and the client or device, the latency is high. I mean, I don't know if you have time to yourself. If you ask Alexa what's the weather, it will take about 1 to 2 seconds. And certainly when the data is sent to the server, in a sense, it compromises your data privacy. So for translation, people have been moved to non-autoregressive translation. And instead of output, the output results kind of token by token, it output everything in parallel. And the challenge here is, how do you know how many tokens will be in your output? When we talk about translation, it is fine because, I mean, like, if you output 8 words or 9 words, I mean, like, you can still adjust it a little bit. But for semantic parsing, the output is actually quite rigid according to the intent ontology. And what shall we do? So we do 2 things. The first thing is we try to fix the size for the slots. And here the content is I'll be there at 6 p.m. and it could be 5 words, it could be 15 words. And what we did is instead of getting the words, we get the index of the words. And the benefit here is, since this is sort of continuous numbers, then we can just get to the first index and the last index. So now the slot output size is fixed. Okay, so this is the first thing we do. But secondly, for the different intents, it could still have different numbers of slots. And according to the input, we might fill different slots, different numbers of slots as well. And what we do here is we add a layer that would predict what is the length for the output. And here we predict the output will have 6 tokens. And that's we parallelly generate these 6 tokens. So this is a full model, and we get the input, we get their positional embedding, and then we encode it predict the target length, and using it to generate the masks, taking both the encoder representation and the positional embedding for the masks, and then decode it. So with this model, our memory usage has dropped by 83%. The latency has dropped by 70%. The quality is higher than the state-of-the-art non-autoregressive methods. And also when we do cross-lingual, we improved the quality by 14% comparing with the autoregressive baselines. Okay, so that's the first direction. The second direction is that you see through the glasses, and then we want to have a multi-modal assistant. So for understanding, we want to understand not only the voice, but also the vision part. And we add computer vision part to understand what we see. And then we add multi-modal understanding to fuse the voice signals and vision signals. And similarly, for output, we might generate the images and send it to the users in some way. The related areas includes computer vision and a multimodal conversation. So here I want to show you another piece of work. By the way, so here the work I'm showing you are kind of representatives to illustrate what we can do. And there are a lot of other works and publications from the org on this. So in this example, we already get some conversation history. I want to buy some chairs. And then the assistant said, great, how do you like these ones I found? And then the user said, I like the brown one, show me the back of it and tell me about the materials. So the history and the utterance are encoded and sent to the multimodal fusion. And then meanwhile, we send the embedding of the picture to the same component. And as you can see here, we use the utterance, voice utterance, to attend the image encoding, embedding, and then concatenate the utterance with the new image embedding. And that will be sent to the next two components where we predict the action and we generate the response. So for example, here it will say, okay, the action is to rotate this sofa, and then the response is, this is how the back looks like. It has a solid brown color with a foam fitting. And we tested on two data sets. One is furniture, one is fashion. And as you can see, when we do this multimodal fusion, the F measure for intent classification increased a little bit for fashion, drops a little bit for furniture, but for the sloths, it increases a lot. Okay. So the next direction is the context. We wear it everywhere. And so now the glasses will know much more about your context. And those contexts will be collected and sent to the understanding component. So the component is not only multimodal, but also context aware. It will also be sent to the dialogue planning part. So the planning will be context aware as well. And let me tell you a little bit more about what we mean by context and what we do for using it. So for context-aware assistance, it will examine the surroundings. And such context includes time, location, things, activities, events, basically where you are, what time is it, what are you doing, who you are with, and what are your surroundings. Those are the context. And based on that, it will use the context to personalize the experiences. So for example, it could improve the reactive services. When you ask for messages, it could rank according to your particular location. And it could send you reminders based on your context. And that is kind of enabling the proactive services. It can also give you some recommendations according to your contexts. So that is this picture. And I don't know how much you have heard about contextual AI. And according to DARPA, that is the third wave for AI. And the first wave is last century, and that is symbolic AI based on handcrafted knowledge. The second wave is the past 20 years for statistical learning, such as deep learning. And for next wave, we want to do contextual adaptation, personalization based on the context. And so here, we are doing a lot of work here, and I don't have particular publications, so I can't say too much about it, but just to let you know how important this could be. The next direction is recommendation. And with the context, we can even proactively trigger some of the services. And let me give you some examples about personalization. And another area, by the way, related to this is federated learning. And I can show you some of the key ideas behind it. And let's start with kind of a recommendation part. This part is not proactive. This is more of a reactive, and it is called conversational recommendation. So let's say you ask, hello, I'm looking for a good place to eat. And then the assistant will look at the places you have visited. And this is captured using a graph called memory graph. So it found a lot of restaurants you have visited are from downtown Phoenix. And then it will ask you, hey, is downtown Phoenix a good place to start? Let's say the user confirms it. And then it will look at those restaurants, figuring out that some of them are kind of have American cuisine. And then it will say, hey, you ordered American food a few times. Do you want to try something similar? And just to add that, once the user asks to get from downtown, an additional edge is added to say the user has informed the location. And now let's say the user said, okay, he is in the mood for some barbecue, and that is added again as some preference. And then the system will find this barbecue restaurant. So if we look at this memory graph, it basically combines the public knowledge graph with all of the restaurants, their price, cuisine, location, and so on. And also the personal knowledge graph, where the user has visited, and possibly some other information. And the nice thing about this graph is that we actually do not need to know the content in the graph. We just need to know the graph structure. And then we can send that as part of the input to this neural network model. And another part is basically the dialogue going through an LSTM layer, and use that to predict what should be the dialogue action. And this graph can also give us the ranking of the items for recommendation and for the next step intent for the slots and so on. So this is regarding how we use the personal and public knowledge graph to do conversational recommendation. Okay, so this is one way to do personalization. And by the way, just to show you an example here, basically here, each column is one choice restaurant. And as we can see, with the user giving some of the input, some of the choice get darker color, meaning the assistant is more confident on that answer. And some others will get lighter color, less confident, because it may not sort of satisfy the conditions the user asked for. The next way of doing personalization, just as one example, is federated learning. And then normally when we run model, we push the data to the model. Federated learning is different in the sense that it pushes the models to the data. And what do I mean is, at the server side, we train some model, we send a copy to each device. And then on the device, we will get the user embedding for that particular user and use that as part of the input to the model and generate the best results. And again, this is personalization, but slightly different from using a personal knowledge graph. And so with all of this, like proactive services, recommendations, personalization is super important. And how to do that, there are still a lot to do. Okay, so just to recap all of the research areas related to this. This is the full architecture, and research areas related to it includes computer vision, multi-modal conversation, contextual AI, on-device learning, personalization, federated learning, so on and so forth. It's a lot of new technologies we need to invent to unblock the fancy features we could enable on the AR/VR assistants. With that being said, so to be extremely honest with you at this moment, I do think about those fancy features, but what keeps me sort of worried every day is actually physics. So what is the memory we could have put into the glasses? And how about the battery for my very fancy feature? How long can the battery support it? And how about thermal? How can I make sure the glasses does not melt on my face or sort of burn me? And these are the real problems we need to face when we do all of this on-device machine learning. And for those of you who might know me, know my past work, in the past 20 years, I have been working on knowledge graphs. And if you ask me what is my dream is to have a lot of data. And in my dream, trucks are coming to me with data so I can use it to enrich the knowledge graph. And then now I started doing this on-device assistant, this AR/VR assistant, and it is quite different now. And what is my dream now? My dream, to be extremely honest with you, is that everyone has a big nose. And so we can wear a computer. And now with the computer, you have a lot of memory, a lot of battery, and you have this fancy sort of fan, and it will never sort of get too hot. Okay, so with all of this, several key takeaways. An ideal intelligent assistant should be an agent that knows you and the world, so be knowledgeable, can receive your requests, reactive mode, or predict your needs, proactive mode, and provide you the right services at the right time with your permission. An intelligent assistant is essentially a conversational system. It could be task-driven or information-driven. And for the next generation AR/VR assistants, it will require a lot of new research on on-device learning, multi-modal conversation, contextual AI, federated learning, recommendation, personalization, and so on. So with all of this, I will end the talk and welcome questions.
Yeah, thank you very much for the talk. Now, We are open to questions. There are already 2 questions in the chat area. Maybe I can read the question and then you can answer, and people feel free to unmute yourself if you have any further questions. The first question is from Alec Wang. Is state in most conversation systems tracked by users, perhaps by voice or per network of devices?
Sure. Good question. The state is not tracked by the users. The state is more of tracked by the dialogue system. And you can consider in the end-to-end dialogue system, basically the input is the input text from the user. And then the output has 3 parts. One is what is the action? And the second one, plus the parameters for those actions. The second one is what is the new state for the dialogue. And the third part is what is the response, oftentimes text response to the users. So it is tracked by the dialogue system.
Vivian Cole has a question is for in-device models, do servers push retrained or newer version models to devices?
Yes, that's true. Yeah, so when we retrain models, and you will be asked to sort of update your device. And for ribbon stories, as an example, we sort of periodically need to update it. And because we our work do a lot of the sort of experience development, and every time we have a new version, and then my ribbon story will send me a reminder, hey, you should update it.
Great. Anyone have questions?
Hi, Professor Zhong. I have a question. So it looks like the system you introduced is looks like a very complex and system. So I wonder, like, how do you, like, when you develop it, like, how do you test it, like, to make sure this is usable for everyone, and to make sure that you cover the corner cases and other things. And for example, when you deploy it and the user has a feedback, give you something that they think is not correct, how do you know, like, which part is wrong in your system? Thank you.
Mm-hmm. Okay, that's a great question. And so there are 2 parts of the answer to your question. And the first one is there are many sort of complicated systems, even for Google search as an example. I mean, like many different components are actually invoked before you see the whole sort of a screen of answers. And we sort of generate something called task satisfaction rate. And we track the user sort of actions. Sometimes the user would say cancel, and then something must have happened. And then we will see, okay, what went wrong that the user wants to cancel. And we have some way to automatically track that. And then meanwhile, we also generate like manual sort of annotations to get some human labels, manual labels to track the quality. And then we basically go back to sort of, when we see the errors, we will have some idea about which particular component might be going wrong. So that's one part of the answer. Another part of the answer is actually quite unique for the system when we want to make sure we preserve the privacy to the users, because we may or may not really track, keep all of the information. And that's a very big challenge. And I didn't cover it here because of the time, but we are also using some federated analysis generation. And so without really tracking the user data, we will know, okay, this is a statistics, and so this is then the quality of our service. And some part of it will be kept for a short period of time, and so we can sort of look at the data and figure out what is wrong. But that's definitely extra challenges I'm sort of getting into at Meta when we develop this AR/VR assistance.
All right, thank you very much.
Thank you.
Oliver, you unmute yourself. Do you have any questions?
So
oh, and there's one in the chat. Yeah, I can go after the chat. So whatever.
Oh, okay. Maybe I can have one question. Just imagine that I'm asking an assistant how to operate a special machine. And instead of giving me a long instruction of 10 steps in a shot, it may be more understandable that it can tell me step by step. And also because the classes can see whether I do it right? Maybe repeating some of the steps if I miss them.
Yes.
So here, I just wonder how we can measure the understandability or the kind of successful satisfaction rate you just mentioned in a multimodal setting and also in a real-time setting. Do you know any work on this direction?
Great question. And again, two parts of answers for it. The first one is normally when we rate the answers returned to the user, both for Assistant and for some other sort of, for example, Google search or anything, we kind of have a different ratings from 0 and actually oftentimes from -1 to, let's say, 5. And 5 means this is really great answer, and 3 possibly means this is a acceptable answer. And I'm saying -1 basically means, okay, this is ridiculous answer, or this is even offensive answer. And then those things are considered when we generate the rating. And taking you have a great example, and even for like something simple like for dialogues, when we generate the responses, and we can generate some like unnatural responses, sort of given the same information, and that will be a level of 3 instead of 5, for example. Yeah. But I really like what you said regarding step by step, and let me give you another example, like direction. And one thing you could imagine for AR devices is you wear the glasses, you want to go somewhere, you don't need to get out of get your iPhone, mobile phone out of your pocket, and then you see that sort of arrows going left, going right, going straight, just from your glasses. Yeah. Okay. I'm sure AR devices will enable a lot of cool use cases for such cases.
Yeah, that's true. Yeah, let me give you another situation I think may be interesting. Okay, suppose just imagine I'm in a store. I'm looking at one Saucony running shoes, and then I'm going to pay for it because the AR, VR, I mean the smart assistant, the glasses can do payment too, right? Now the challenge is how much Nike or New Balance need to pay to ask me turn my head 90 degrees to look at another pair of running shoes of their brands. This is related to recommendation, related to the interaction between the assistant and the users, and also related to moral AI, right?
Yes. Yeah. And plus, I mean, it's that's a great example, and it's also related to integrity, AI integrity, because I mean, like, as we provide all of the services recommendations, sometimes the users really would not appreciate if we control them.
Yeah, exactly. You're right.
Yeah. Okay. I also saw some questions from chat.
Yeah. Do you want me to read it?
Yeah. I can read it. Thank you. Okay. So there is a question from Alex Wong. For federated learning, is a model retrained every time a model is updated on device? Yes. And because we push the model to the device. Yeah. And actually, sometimes every time you sort of turn on the device, it will push something to your device. And the next question is from Meishun Jin. And it says, for multimodal fusion, our brain can do it naturally. What are the challenges do you face to fuse sentence and image? What is your solution except for attention? That's a great question. And so far, for the multimodal models we have developed, both at Facebook and at Amazon, normally we just have a transformer and then send stuff into that transformer. And that stuff is basically the embedding for natural language, the embedding for the images, and sometimes we get the OCR results from the images and send it to the transformer. And there are many new challenges that this does not work. And the transfer learning or the how to sort of get into new domains, that's always an issue. So that's number one. And then number two, for the assistants, I mean, when it is on device, I honestly don't have an idea how much it will cost to do multimodal. And so far, we only tried CV only or voice only, and we haven't done much of combination. Or we could do rule-based sort of combination, and we haven't trained a big model to get everything in. So a lot of things that seem to be natural when we have big machines is impossible on the devices. So I would say that's the biggest concern or challenge we have.
The one question by Shen Wang is that personal knowledge graph is growing. How to deal with the knowledge graph growing? An active learning or incremental learning approach? And personal knowledge graph is also related to contextualization. Contextualization requires a lot of user information. Do you think it is feasible to obtain for personal knowledge graph construction? The third question is that for the knowledge graph, is it limited to traditional knowledge graph? Do you think the knowledge graph will extend to multimodal knowledge graph? It is a long question.
Yeah. So let me start with the first two. Actually, both of them are talking about the graph growing and whether or not it is feasible. I think yes and no, that the graph is growing. Definitely the graph is growing, but it does not necessarily grow in this way, and it will flatten out. You go to a restaurant, and the first time it will be added to the personal graph. The second time you say, okay, visited twice. And the third time, fourth time, you just update the visited times, and it does not increase the size. So that's one thing. The second thing is, as human beings, we forget things. And the same for your personal knowledge graph. And it could get bigger and bigger, but you don't need to load everything into the current inference graph, or even like load to your device. That's even more expensive. And you only need the part that is related. And I mean, you possibly don't need to know which restaurants you have visited with your family when you are a teenager to make a decision now. And we should also forget stuff in the personal knowledge graph. Forgetting doesn't mean we delete it, we just put it aside. And the next question regarding whether or not the knowledge graph will extend to multimodal KG, that's a great question. First, it has to be multimodal to support kind of a multimodal understanding. And when we look at something and we say, okay, what is that? What is the breed of that dog? And we need to know what that dog looks like. And for each breed, we need to have some of the sort of pictures related to it. And so I think that definitely is related. But on the other hand, it doesn't say, I mean, every time we need to get those pictures for the KGs, because eventually, I mean, as you know, for computer vision, those information is kind of already incorporated into the modeling. And so that comes to a different question. So shall we model all of the knowledge explicitly, or some of them can actually be modeled implicitly in the text and image embeddings?
Any further question?
Hello?
Please. Yeah, we can hear you, Daniel. Go ahead.
Thank you for your great work. And I just have like a quick suggestion, because it's like in this area, we have to incentivize a lot of privacy information. So we have to make a lot of like incentive mechanism. Like you just said, if you look around, am I going to be paid to look around at other Nike brands? That falls in the domain of like, people trying to give you some incentive mechanism so we can attract a lot of people to share their private information. And it's really great. And I like what you have going on. And then it's like an interesting research area I would like to look at. That said, I really have like some few concerns that I was thinking about since you talked about latency and then accuracy. And then I wanted to ask, the latency in this case, is it like comparing your entire system to the existing models? Because it looks like you have like a lot of things faceted in your system. So I was thinking maybe that would be like that would make it a little bit maybe slower, but if it's still increasing, I just like to know what are some factors that contribute to that. And then when it comes to like the federated learning model, because I know usually maybe you might have a trade-off at that point if it's latency or if it's accuracy, because you are not getting access to the exact parameters compared to the existing models that maybe like centralized training, or they go to a traditional training. So is there like any trade-off when you introduce federated learning at any point?
Okay. So first, I fully agree with you. I mean, like how to do personalization, preserving privacy, this will be super important and possibly will become a hot research area, because now we see more and more restrictions for the devices. And regarding federated learning, currently we already launched some of the federated learning models on the glasses. And so it is doable for simple stuff, and not necessarily yet for very complex sort of comprehensive models. And another thing I want to say is eventually you will find the quality and the size of the models, there is a trade-off. I mean, certainly, I mean, we could get to the quality when we have endless of resources, and that's kind of the ceiling. And then when you deploy it to the device, eventually you would say, okay, am I going to reduce it by 20 times or by 40 times? And what quality do I get? How much of the sacrifice is for that on the quality? So there is this trade-off.
Thank you.
Thanks.
Great. Any further questions?
I have one question here. My question is that when you talk about the assistant always care about privacy, that's important, but is it possible that some people or some situations we don't want the privacy or don't care about privacy? For example, in the meta world, for example, people may don't know who I am, or sometimes when I see the movie many years ago, the movie called Truman Story, for example. So some people just don't care, but we wish to have a more quick or more precise response from the assistant.
Yeah.
By this situation or situation, but some other people maybe have lots of time to kill, so wish to help people too. So by this way, may able to get some human help to assist the assistant to do the work.
That's a great question. And so for our assistants, there is opt-in and opt-out mode. and the users could choose whether or not they want to opt in to have less concern on privacy or not. And even for particular app skills, etc., it's similar. Like for taking phone apps as an example, you can choose whether the app could access your location. Is that once only? Is that when you use it? Or is that always? I mean, there are always things to choose. The thing here is that even though we might be able to make some smart decisions for the user, but we still want to give users the control. They will decide whether they care about the privacy.
Okay, thank you.
Thanks.
Just a follow-up. So your model kind of like profile users, right? Is it able to learn each user and be like, okay, so knowing you care about this, is there a way that your model does that? So it's able to determine that, hey, I know you don't care about privacy, so this is what I'm gonna focus on. Or I mean, you care about privacy, so I'm gonna have to. Does your model do that concurrently on the system?
Mm-hmm. I'm pretty confident that we could get a model to decide for a particular app whether the user will care about the privacy for that app. I guess it's much more of a production choices rather than sort of machine learning capability choices.
That sounds good.
Great. The last call, any question? Yeah, with no further question, let's thank Nuna again. Yeah, thank you so much for this very inspiring and also insightful talk. Yeah, you can see people all enjoy that. Yeah.
Thanks a lot. Really appreciate all of the discussions and I enjoyed it a lot.
And also thank you for all attending the seminar. Next week, the same time, Professor Tamer Ozu from University of Waterloo will present a systematic view of data science. And definitely that will be another very interesting talk. You're all welcome to attend, and follow-up email will be sent to you soon. Thank you. Yeah, thank you, Luna. Have a wonderful evening. Thank you, everyone.
Bye.
Thank you. Bye-bye.
Bye-bye.